Hello, everyone. I'm audible. So fine, guys. I think I'm audible to every one of you. Right. Let's start with the class. So I think in last class I was talking about linear regression, right? Or we have just started with the machine learning part, right? So it will be a continuation of same class, and so many things I believe we have already discussed. So let's try to. So basic was already discussed, right? What is machine learning, and then like parts of machine learning, different sections which comes under machine learning, right? Or how data science is aligned, or what is the data industry. So I believe these are the things that we have already discussed, and some sort of like a linear regression. So we had started, right? So we were talking about a data set, we were talking about like so in case of machine learning, so we always try to find out basically a relationship between a data. So these are the things that we have discussed. Now let's try to take one situation over here, and let's try to understand how machine actually learns. In brief, I think we have already discussed. I hope you all are good, and anyone is not having any kind of a doubt. So anyone who is having any kind of a doubt, so you can ping me in a chat box. I believe I will be able to answer. Yeah. Okay, so okay, join previous week, no issue. We have to go through our recordings for sure. Yes, and then and just keep on attending these classes. I think it's fine. Yeah, fine. Let's try to talk about it. Okay, so I was talking about the linear regression, right? And as we have already discussed, that it's nothing but if there is some relationship between a data, if your data set is going to show you some sort of a tendency that yes, I have some linear kind of relations. So in that case, we can try to draw one line across this one, right? Which can try to generalize an entire relationship between all of this data. Now, my data set can be anything, right? It may be, it may looks like this one, it may looks like this one, it may looks like this one, doesn't matter. But everywhere, what is common over here is that I'm just trying to generalize. I'm just trying to generalize a complete relations, and based out of that, I'm trying to draw a line. A reason behind drawing this particular line is nothing but I have to find out the equation, a equation which can try to define a relation of this data or this particular trend or this particular pattern. That is my objective, and that is the reason. So we are trying to draw this line, right? Any kind of a line. Maybe if my data set looks like this one, right? So if my data set looks like this much, so in this case, what I will do, so I will try to draw maybe this kind of a line, right? So this is a line which is trying to generalize the entire data set. There is a possibility that my data set will looks like this one. So maybe a sinusoidal kind of a wave, right? So maybe in that case, I will try to draw this kind of a line, a sinusoidal line, right? So all of these lines, I can clearly say that we can try to represent all of this line in some sort of a equation, a mathematical equation for sure. This is a sinusoidal line. This is the line for the parabola, or I can say this is the straight line, right? I may have a circular line. I may have a zigzag kind of a line, but every line you will be able to define as a equation. So I'm supposed to find out, again, when I'm talking about an equation, so in every equation you will be able to find out some sort of a variable. So here, if I have to represent this particular line, so maybe I will have to write y is equal to sine of x, right? So this is how I'm supposed to define this particular line. Y is equal to sine of x, right? Maybe some constant over here or some variable by which I will be able to define maybe a magnitude of this sine wave, right? Maybe a 2x or maybe mx. I can try to define. So in the similar way, for all of these lines or for all of this kind of a data set, I have to find out certain equation, a equation which will be able to showcase a tendency of my complete data set. This is what we do. This is something called as machine learning in general, finding out a pattern. Again, so going forward, you will get to know that sometimes it's very difficult to find out or like to observe a definitive pattern inside a data, which I can represent by using some of the constant equation. And this is where a different kind of algorithms comes into a picture, which we are going to study, like a random forest, XG boost, gradient boosting, right? So there are so many different kind of equations. Then we will start exploring in that particular circumstances. But as of now, it's just a beginning. So I'll try to work on the line part, and we will try to understand how a line is going to define a pattern. Okay, so here is my data set, right? So here is my data set. I'm trying to draw a line. So fine, I will try to draw some sort of a lines over here. If I have to write down equation of this line is nothing but mx plus c. We have already discussed, right? So where m is nothing but your slope over here, c is nothing but your intercept or a distance of y, or maybe a unit of y when x is equal to 0, right? So this particular thing is called as c over here, or you can say it's called as intercept, right? So m is called as slope, c is called as intercept, or you can say m is nothing but it's a proportionality constant, and c is nothing but it's a error. So there are different names you will be able to find out, and I believe I have already discussed about these different kind of a name in my previous classes, right? So somewhere it's called as m is called as slope, somewhere it's called as like a proportionality constant, somewhere you will be able to find out it's like called as a kind of a variable, or kind of a constant, not a variable, kind of a constant, which is showing us a correlation between y and x. C is nothing but it's called as intercept, it's called as error, and many more names you will be able to find out in a different perspective, but everything is same at the end of the day. We are just trying to draw the straight line, nothing else over here. Now here, let's suppose I have drawn a straight line, y is equal to x plus c. So this black line is basically representing a straight line. Now, what I will do is, so let's suppose I'll give you one input. So this is my x axis and this is my y axis. I'll try to give you one input, right? I'll try to give you one input, let's suppose. And then I will ask you that, okay, so what is a possible y value you will be able to find out, right? So this is my input I will try to give you, and then I will ask you that what is a possible y value you will be able to find out. It means final prediction you all will be able to find out. So it's nothing, right? So I'll try to input this x value inside this equation. I will be able to find out y as compared to this line. So yes, I can try to draw maybe a straight line in this way, right? So this is going to be my y, right? And we used to term these things as y hat, a prediction one, because we are going to get this particular value out of our line. So for this input, let's suppose this is x1 as an input. So y1 hat I'm able to see, or I will be able to get. So how I'm able to get y1 hat? Again, from the same straight line, right? So just on this line, so I'm just trying to send a value, and then m and c I already know because I know about the straight line, and for sure I will be able to get a value of y over here. So for any value of x starting from minus infinity to plus infinity, you can try to give an input, right? And you will be able to see a respective y values if we are able to define a straight line. Now every values will depends upon this straight line, or every values are trying to follow a same trend of my data set, right? Because line, straight line itself is showing us a same trend over here. Again, there is no issue and there is no problem. So once I will be able to find out a value of m and c, and I will be able to draw a straight line, which we have seen last time, that how manually we were able to calculate a value of m and c. Even last time, so with respect to weight and height, so we have already calculated a value of m and c, and multiple values of m and c we all have calculated, and we have validated that, okay, fine. So which value of m and c I will be able to accept. This is what we have done last time. Fine. So this is the situations that you will be able to find out. But let's suppose I have drawn this straight line. How I will be able to say that what is a accuracy of each and every like a value or each and every prediction it is able to give. So last time, like a lump sum value you were able to observe, right? But here that is not going to work. We are supposed to say that, okay, confidence of this particular prediction is maybe 90%, maybe 80%, maybe 95%, maybe 60%, 20%. So you have to talk about actually an accuracy, right? You have to talk about a accuracy. Unless and until you are not able to talk about an accuracy, so for sure you will not be able to talk about the confidence score of this particular line. So it is going to give me a prediction. There is no issue, right? I'm able to get y1 hat. There is no issue. But what is authenticity, or what is like a term by which I will be able to define that this value is maybe 90% accurate, or maybe a 95% accurate, or maybe 99% accurate, or maybe a 60% accurate, right? So how I will be able to define that particular term? And this is where, right? This is where R square or residuals comes into a picture. But before a residual, just a minute, guys. Okay, so here is the thing, right? So here what we are trying to do is, so we are trying to pass a value of x, and our objective is to say that, okay, how accurate this line is. That is our one of the objective, and that I will be able to define once I will be able to find out a term called as residual. Now what is a residual, by the way? We'll try to understand. But before that, even before that, before finding out a residual, so we have to even find out that how m and c value is been calculated by a machine, right? Not by us. Last time we were trying to do this calculation by ourselves, but that is not a way that we are going to follow. Machine follows a different kind of a way, and before that, so we will try to understand that particular part. And before that, right? And before that, so you are supposed to understand, or you are supposed to know that when you will be able to build, or when you are supposed to do a linear regression, unless and until you are not able to understand that, you're not even supposed to apply a linear regression. It's not like if my data set is showing me a linear tendency, I will go and I'll just apply a linear regressions over there. So let's try to understand these assumptions, that in which case I'm supposed to apply a linear regression, right? So first of all, one thing is very much common. If I'll talk about like point number one, so there must be some relationship you are supposed to find out between y and x, for sure. Then only you are supposed to apply a linear regression, and that to a linear kind of a relations you are supposed to observe. Now point number second, if I'll talk about, right? Yes, linear regression is obviously like it's important, right? The second thing is a mean of residual should be equal to 0. So mean of residual should be 0. Now, what is the meaning of it, right? So mean of or average of this particular term, because each and every time, let's suppose if I'm trying to find out a residual, I'll tell you how to find out the exact residual, but average of residuals are supposed to be 0. Then only you are supposed to accept a particular equations. These are the assumptions again. So like no need to remember as of now. So just try to observe these things, right? Now, the another assumptions you are supposed to establish over here, that your error terms are not supposed to be, error term are not supposed to be correlated. Again, I'll be talking about it. So every point we have to discuss one by one. Then only we'll be able to understand these equations in a better way. So error terms are not supposed to be correlated. What is the meaning of it? Let's try to understand. But this is the assumptions. Without this, you are not supposed to build any linear regression equations at all, right? Now here, the another term is independent variable x are uncorrelated with the residual term. So you are not supposed to correlate, or x and residuals are supposed to be uncorrelated. uncorrelated. Now there are fifth assumptions called as, so at any point of a time, your error term that you will be able to find out must showcase a constant variance. Again, so variance is nothing but it's a statistical term, right? So error term constant variance. A sixth assumptions that we have over here is there should not be any multicollinearity. The seventh term that you will be able to find out that error terms are supposed to be normally distributed. So this is the assumptions we are supposed to keep, or this is the assumptions we are supposed to create. And if our equations are going to fulfill all of these six assumptions, then we can say that, okay, so whatever value of M and C that we are able to find out, it's good to go. And I will be able to accept this value of M and C, which is going to define a straight line, or which is going to define a relationship between my data set. So one by one, let's try to understand all of this 6 point, and let's try to clarify our doubt. So hopefully in today's class, we will be able to clarify this kind of assumptions, and we will be able to understand this relations or this equations in a much better way, right? So here, let's try to talk about, first of all, what is a residual, right? So let's try to understand this particular part. Let's suppose if this is the situation, and this is the straight line which I have drawn. This is the straight line which I have drawn. There are certain data set which I had, and for these data sets, so I have drawn these kind of a line. Okay. Now, what I'm trying to do over here. So let's suppose this is one of the data point I have chosen, right? Which was a part of my original data set as well. Now here for this data set, this is my X, right? And this is my Y by default. So this is my X and this is my actual Y, which is given to me. But for the same data set, if I'll try to do a prediction on a straight line, so this is what you will be able to find out. So this is my actual Y and this is my predicted Y. I'm just trying to represent my predicted Y by Y hat. Now here, can I say that there is a certain difference in between my actual Y and a predicted Y? Everyone? Yes. So we have some sort of a difference in between my actual Y and the predicted Y. Points is same, right? For the same point, which is given inside my data set. So actual Y was given to me. And when I'm trying to do a prediction, so yes, there is some differences I'm able to find out. Now let's suppose equation of this straight line is Y is equal to mx plus c, right? So can I say that this Y hat or this Y hat is equal to mx plus c, right? Y hat is equal to mx plus c. Now if I'll ask you, can you please tell me what is a difference between actual data and a predicted data? So what will be the difference? Can I say that Y minus Y hat maybe, right? Or vice versa, for sure, right? So Y minus Y hat. Now, how I will be able to represent this Y hat? So can I say that I can replace Y hat by mx plus c? This one, this is my Y hat, because this is the equation which is responsible for giving what? Output, right? So I can try to represent this one in this particular way, right? So Y minus Y hat is nothing but it's a difference in between my original value, means outcome which I was looking for, and the expected value. Now that is something called as R, or I can say this is called as residual. So in my observations, when I was talking about these 6 points, I have mentioned residual in a multiple places, and in between a residuals, we have to work a lot, right? There are multiple points which depends upon a residual itself. So let's try to understand residual. What is the actual meaning of a residual over here, which actually I'm talking about, right? Then I will be able to understand this 6 point in a much better way. Okay. No issue. So here, your R is what? Your R is nothing but this distance. This entire distance is called as what? It's this entire distance is called as basically a R, or you can say it's a residual, which is obviously not, it's just a distance between my Y and Y hat. Close. Now, here, what we are supposed to find out. So let's suppose if there is some points over here. Let's suppose if I'm talking about maybe another point, right? So if I'm going to talk about this point, now for this particular point, right? So what is my original Y? Can I say that this is my original Y, right? And what is my predicted Y? So can I say that this is my predicted Y? This is my predicted Y. Agree, everyone, right? So again, Y minus Y hat, I can try to find out the residuals. And again, based on the values, so it is going to give me positive, or maybe it is going to give me a negative one. Depends, right? So here Y is bigger, here Y is lesser. So for sure, somewhere it will give me positive, somewhere it will give me a negative one. So we are supposed to eliminate this particular factor. We are supposed to eliminate this directions, and we are supposed to just like depends upon the distance part. I'm not supposed to like say that, okay, fine, so I'm moving in left hand side or maybe a right hand side. What I'm supposed to say is a distance, maybe a 2 kilometer, 3 kilometer in this particular way, without any kind of a sign, right? Without any kind of a direction. So here, what we can try to do is, so maybe we can try to square it, right? So maybe we can try to square it. So if I'm going to keep a square over here, so for sure, I'm supposed to give a square even in this particular place. So fine, squared it, right? Now this is something called as residual square. Now, can I say that it will be independent of any kind of a directions, right? So negative, positive, doesn't matter. At the end of the day, it will be positive. So it is going to give me basically a distance. Distance between what? Distance between these 2 points. It is going to give it to me, and it will be independent of all of those things. Okay, no issue. Now, can I say that if I have hundreds of data, right? If I have hundreds of data, so for all of these hundreds of data, I will try to find out, right, a multiple residual for all of these hundreds of data. Yes, everyone? So for hundreds of data, I will be able to find out a multiple residual over here. Okay, fine. So what I will do, summation of I is equal to 1 till m. M is nothing but my number of the data set, right? So in both hand side, I is equal to 1 till m, I can try to put, because I'm trying to find out what a summation of a residual of each and every data set which is available inside my observation. Okay, right? So it's a very simple intuition that we have a multiple data set, and I'm just trying to like put basically, so we have started ahead with this equations, and now this is the equations. My objective was to find out what. So I have hundreds of data set. Based out of that, I'm trying to build a line, right? So this is a line, the line that we are trying to draw, a line that we are trying to build. We are supposed to build in such a way that from a residual to its line, right? So can I say that I'm expecting a kind of a line where summation of all the distance of this residual should be minimum? In that case, can I say that it's a best possible line, right? If this distance, summation of a distance of all the data set, not just one, right? All the data set, if it will be equal to a minimum or close to 0, right? So in that case, can I say that I'm looking for such kind of a line, right? Where prediction as well as a data set, a data point should be on a same line. So it is applicable for each and every one, each and every points. So that is the reason. So we are trying to find out summation. So we are looking for a line, or we are looking for a prediction. So where summation of residual of each and every data set on top of this line must be equal to 0, or maybe a minimum. Residual must be minimum, or errors are supposed to be minimum at any point of a time. So, okay, this is the equations which we are going to derive in this particular place. No issue, right? So we can try to like define this kind of relations. Now here, right? So here, if I'll ask you that, okay, so can you please try to break down these things? So if I'll ask you that rewrite this entire equation, so maybe I can try to rewrite this equation in this way: summation of I is equal to 1 till n r square, summation of I is equal to 1 till n y minus mx plus c, right, square. Now if you have to expand this equation, so how you are going to expand this particular equation? Y squaring, sorry, got confused. I think I have already clarified these things, just to remove your direction factors, just to remove your negative factors over here. So we are trying to square it. I think I have already clarified each and everything. Yeah. Okay, so I think we all know about what is the what is the formula for a square minus a minus b square. Yes, I believe we all have studied, right? So some of you are saying a square plus 2ab plus b square. I think you should attend 10th 8th classes again, I believe, or maybe by mistake you have written. Yeah, so can I say that we all are aware about a formula: a minus b of a square is nothing but a square plus b square minus 2ab, right? We all are aware about it. And can I say that this is the same thing? Yes, okay, no issue. So y square, right, plus mx plus c square minus 2y mx plus c. Is it correct for everyone? Yes, okay. So fine, we can try to expand these things further. So y square plus m square x square plus c square plus 2mxc minus 2y mx, right, minus 2yc. Can I say that this is the equation? Yes. So this is the equation of what? A residual. This is the equation of a residual that we are supposed to, or that we are able to find out, right? So okay, no issue. So maybe just a minute, guys. Yeah, fine. So this is r square is equal to this one. So this is the equation, right? So we are able to find out in this particular place. That is completely fine. We all are able to find out r square. This is, and then we can try to add summation of I is equal to 1 till m, so that I will be able to find out these things for an entire data set. Now, what is our objective? Let's try to understand that particular part. Yeah. What is our end goal? What is our objective? Our end goal or our objective is to find out a point where residuals are supposed to be 0. This is the things that we are looking for, right? So we are looking for a point where derivative of residual with respect to, so I think last time I talked about like a 3-pen like a concept, right? So in a 3D, we have a value of m, we have a value of c, we have a value of e. So can I say that we are supposed to bring down a value of e is equal to 0? I think this is what we have discussed, right? Value of e is equal to 0 we are supposed to bring down. So can I say that on a surface, on a plane surface, example which I have given you last time, right? So on a plane surface, derivative of e with respect to m should be equal to what? Equal to 0, right? And derivative of e, error, with respect to c should be equal to 0. This is what we have discussed. So can I say that we are able to find out e over here? Residuals are nothing but errors, right? Yeah, residuals are nothing but this is the errors that we already have. So here, right, so here we are supposed to find out, or we are trying to find out this particular value E, right? So this is nothing but residuals are nothing but it's an error, right? Maybe I can try to define in this way, E square, that is also fine. Now what we are supposed to find out, what is our ultimate goal in this particular place? Our ultimate goal is to find out a derivative of E or residual with respect to M, means your slope. Derivative of E with respect to what? With respect to your intercept or C. So if I'm able to find out dr by dm, and if I'm able to find out dr by dc, and if both is tending to 0, right? Both is tending to 0. So can I say that at this point where both is tending to 0, whatever M and C value I will be able to get, that is the value which I'm expecting? Yes, everyone? So wherever this term and this term will be equal to 0 or tending to 0, let's suppose minimum, right? Minimum. So whatever point I will be able to attend, because I told you last time, right? So in a 3D coordinate, so if I'm trying to move one point, so it simply means that all these 3 points are moving, X, Y, Z. All these 3 points are moving. So I'm supposed to bring down these points in such a way that it will be on a surface. So this is my whole idea, or this is my whole objective. And we know that on a surface, if we are trying to find out a derivative, so let's suppose if this is a curve, right, that we have, so it's completely fine. Here I will be able to find out derivative, here I will be able to see some derivative, here I will be able to see some derivative, here I will be able to see some derivative. But what about this point, and this point? Are we able to find out dy by dx? Can I say that dy by dx over here is equal to 0 at this point, and this point, right? Means what is the meaning of dy by dx? It's nothing but it's representing a slope, right? Your tan theta, or rate of change of one factor, or rate of change of one particular things with respect to other things. This is what it is trying to observe, that how one thing will change with respect to other things. And I think we already discussed about this a lot in our previous classes, right? So this is something that we are supposed to find out. So we are supposed to find out that, okay, fine, so where this one is equal to 0, no issue. So we'll try to figure it out. Yes. So if I'll ask you to do or to find out a derivative, right? So if I'll ask you to find out the derivative dr by dm, so what will be your dr by dm, by the way, for this equation? Anyone who can say what will be your dr by dm? Yes. Okay, so 2mx plus 2xc plus 2yx. Okay, so I think we all know about a basic of differential, right? So if I'll give you y is equal to x square, so what will be dy by dx in this case, right? So it is nothing but 2x to the power 1, or 2x, simple, right? Because we all know that x to the power n, if we have, so in that case n into x to the power n minus 1. This is something that I will be able to find out. This is the only thing which is required over here, nothing else. I think in our differential, so we already know that what will be the differential of sine theta, cosec theta, e to the power x, ln, and all those things, right? That was pretty much common. We all have done those kind of things. But here in this equation, only this part is required. And I believe we all are aware about it, right? So here, if we have to find out a derivative of r term with respect to m, right? And hope we all understand this part, right? Point by point. So here, what will be a derivative of dr by dm of this term, y square? Can I say it will be 0? Because it will become a constant for this dr by dm. There is no m term. I'm able to find out. Yes, it will be equal to 0. Plus, this is the constant term, right? And we all know that derivative of any constant, and even constant, this line, right? So derivative of what? Derivative always try to tell you how this line is changing or how this point is changing with respect to the other point. But if this is the line, there is no derivative you will be able to find out, because y is what? Y is a constant over here. So constant derivative is equal to 0. It's again pretty much obvious. Now, what will be a derivative of this one, this particular term? So can I say that derivative of this one is nothing but m term is there, right? So 2mx square. Agree, everyone? Yes, 2mx square plus what will be a derivative of c square? Can I say again it will be a constant for this equation, right? It will be 0. Now, what will be a derivative of this one? So can I say it will be nothing but 2xc m to the power 1. So 1 minus 1 is equal to 0. So m to the power 0 is equal to 1. Simple. So 2xc, right? Minus 2yx, I believe, right? Minus of 0. Agree, everyone? I think the derivative for this one will be equal to 0. Okay. So now this equation will become 2mx square plus 2xc minus 2yx, right? So I think 2x is common everywhere. So I'll try to take out that common. So in this way, it will be mx, right? Plus c minus y. Yes? This is the equation. So fine. dr by dm is nothing but this particular equations we are able to find out. But again, what is our objective? So can I say that our objective is to find out these things of a place where this will tends to 0, right? So can I say that I will try to equate these things to 0? Yes, I will try to equate these things to 0. So I'll try to equate these things to 0. So that is a point, or that is a value of m I am looking for, right? So that is a point, or like that is the things which I am expecting, or that I am looking for over here. So, and again, so those who are confused, so actually we are looking for a derivative of this one. So this is the residual square. So that's the reason I have represented these things by big R. So big R is actually representing your R square. Yeah. So just don't get confused. Okay. So here is things that you all will be able to find out. So this is like equations dr by dm you will be able to see, or you will be able to find out. Now, similarly, right? So similarly, I will try to do what? So maybe I'll try to find out dr by dc, right? Same equation. The equation is same. It's not going to change. This is the same equation, right? Residual equation. Just we have to find out the differential of this one with c. So dr by dc we are supposed to find out. So once you will be able to find out a dr by dc, I believe we all can find out that one, right? So it will be nothing but it's a 2b plus mx, right, minus y. This is something that you will be able to find out. So dr by dc is done. dr by dm is done for all of us. So what is my dr by dm? So dr by dm is nothing but 2x mx cy. 2x mx cy. Okay. So equation number 1, we are able to find out. Equation number 2, we are able to find out, right? So this is a curve. This is the point that we are supposed to reach out, right? So this is the point that we are supposed to reach out, and here, so it should be equal to 0. So maybe I can start equating all of these things in that particular way, right? So I can, and again, for sure, it's nothing but summation of I is equal to 1 till m, summation of I is equal to 1 till m, because we are trying to find out these things for every point. There are multiple points, as I told you, right? There are multiple points that we have. So whenever we are finding r square, so we are finding out r square for all of these multiple points, as we always do, right? So this is the something that we are trying to do. There are so many points, so there are so many residual. So summation of all the residuals we are supposed to tackle, or we are supposed to encounter in this particular place. Okay, no issue, right? So this is something that we are able to do it very easily. Now, so let's try to do one thing. So let's try to equate this entire equation with respect to 0. So this equation is equal to 0. This equation is equal to 0. If I'll try to break it down, so this equation will become summation of I is equal to 1 till m 2b plus summation of I is equal to 1 till m, 2mx minus summation of I is equal to 1 till m, 2y is equal to 0. Equation number 1 I have converted. And then the second number equation says that summation of I is equal to 1 till m, 2x mc, right? And then summation of I is equal to 1 till m. This will become 2xc plus summation of I is equal to 1 till m, 2xy. It will be minus negative symbol is equal to 0. Equation number 2 I have already converted. The same equation, I'm just trying to break it down, nothing else I'm trying to do, right? So okay, fine. Now in both hand side, if you are going to divide by 2, right, divide by 2, so can I say that this 2, this 2, this 2, this 2, this 2, this 2 will be cancelled out, right? Divide by 2 in both hand side, right? So this 2 will be cancelled out automatically. Okay, so because 2 is common, right? So 2 will be cancelled out automatically. So we are just trying to divide in this particular way. Okay, no issue. Again, so we are just trying to divide all of these things with respect to a 2, right? And now, right, so this is equations which is going to give you a final values of a minima at any point of a time. So how I will be able to find out, let's suppose initially I'm trying to like find out some value of m and some value of c, but how I will be able to find out a best value of m and best value of a c? Let's try to understand that particular part, because that is my objective. I have supposed to find out the best value of m and best value of a c. That is the only and only objective that we have. Apart from that, there is no other objective we have over here. So if I have to find out a best value of m and c, and every time my equations, as and when I will try to add my data, so it will try to shift itself, means it will try to find out the next value of m, next value of m, next value of m each and every time. So how it is going to find out a next value of m? So here m new is nothing but m old minus alpha of, or somewhere you will be able to find out eta of, so here 1 by m, total number of a data, summation of I to m, I can say, right, y minus y hat. This is something that you will be able to see. Now, can I say that this particular term is nothing but it's a residual. So if I'll try to do a square of it, so this is nothing but it is going to be a residual. Now your C new at any point of a time is nothing but C old minus eta of 1 by m, summation of I is equal to 1 till m, y minus y hat. So here, every time I'm trying to update my m value in mx plus c, every time I'm trying to change my line a little bit, let's suppose, to find out the best possible line over here. So how I will be able to get a new value of m or new value of a c, as and when it will try to progress inside the equation. So every time it will be calculated based out of this one. Now this is nothing but it's representing your residual terms. Now if I'll have to replace this entire things, so in a simple way, I can try to write m new is nothing but m old minus eta into delta of e with respect to m, and c new is nothing but c old minus eta into delta of ec. So this is how I will be able to write down. Now, what is the meaning of this delta of ec? So delta of ec is nothing but it's a value, right? A value of e where it will be equal to 0, right? So this is like something that you will be able to find out of this one. So you are just supposed to put this particular equations over there. This is something, or I can try to define delta of E C, or maybe delta of R, capital R. Both is same. Error and residuals are same over here. So this equations is going to give you what? This equation is going to give you a best possible M values, where residuals is always going to be the 0, or residuals are always going to be a minimum one. So that's a final equation. Now, what is the meaning of this eta, by the way? What is the meaning of this eta? So let's suppose if I'm trying to like change my coordinates, or in a 3D space, I'm trying to change. So there is a possibility that this error term that I'm able to get, right? It is giving me maybe 5 value as an error, or residual is equal to 5. Means there are huge differences in between the expected error and the minimum point. Now here, we always try to control, because this particular term, right? This particular term is trying to change my actual value or current value of my M and current value of my C. This is something that this one trying to do. So I have to control this change. It's not like that I will try to like a jump from here to here immediately, even if my error is huge. Even if my error is huge, but still I'm not supposed to take a huge jump, because if I'm going to take a huge jump, it will create a problem for me. For example, so means if I'll try to do a fast learning means fast adoption or fast changes. So let's suppose if you will try to complete a book in a single day, and same book if you will try to complete in a 1 month, for sure you will be able to observe our differences. Yes. So suppose if you are trying to learn something by doing just a copy paste of a code from a GitHub, and you are trying to build something by writing a code by yourself, there will be a differences, right? So in first case, for sure you are trying to adopt very like a quickly, and let's suppose you are a beginner, you're just trying to learn a new things. So if you will try to adopt very fast, you will get so many errors, you will like get confused in between, and you will not be able to build a robust project or robust product, right? But if you will go in a smoothest possible way, step by step, if you'll try to learn, if you'll try to write a code, then you will be able to build a better project. Exact same rule is applicable over here. So here we try to control a changes. So we are supposed to control a changes over here. That's no, you're trying to make a changes between a previous value of M. So it's not like I have drawn this line for the very first time and then next line will be this one. No, right? So maybe I can try to draw this line, right? Then maybe this line. So slowly I will try to converge, right? So as you can see, slowly I'm trying to change a value of M and C, right? So slowly we are trying to change a value of M and C over here. Not immediately you are supposed to change, because that is a bad process of a learning. So you're not supposed to jump. Now, how I will be able to control, right? So a total changes is nothing but this one. This one is going to give you a total changes, a rate of change of R with respect to M. That is the equations that we have derived, and that is going to give you a total changes. That is completely fine. But are we supposed to apply, or are we supposed to just subtract that residual from the original value of M and C? No, not at all. What we are supposed to do, so we are supposed to control that changes. It's not like we are supposed to jump from here to here. Maybe I'll try to go here somewhere, then here, then here, then here, and then I will try to come to this point where my residuals is equal to 0 or tending to 0. So that is the idea. And this is where this eta term, which is called as learning rate, comes into a picture. So learning rate is something which always try to control a changes. So let's suppose this has given you value is equal to 5, right? Now eta is equal to 0.001. So what is our total changes I will try to apply? So let's suppose my previous M is equal to 21, right? Now what will be the new value of M? Slope of the line I'm going to change. So can I say that, so new value is nothing but 21 minus 0.001 into 5. So that is going to give you your M new value. So can I say that this change is a minor changes that we are trying to do? Yes, everyone. Yeah. So this is a minor changes that we are trying to do. Now here, a learning rate is nothing but, or this eta is nothing but, it's a constant parameter or hyperparameter that we used to give. And according to a Google Tensor board, which I'll show you in your deep learning first class itself, right? I generally showcase that diagrams and it's a UI interface where you can try to play a Google Tensor board playground, right? So according to that one, a learning rate can range in between 0.00001. So 10 to this one. Ideally, 0.001 learning rate is a good one, right? So learning rate is nothing but it's a constant that we use to define, and it's an experimental thing. No one can tell you that what will be the learning rate for what kind of a data. No one, right? No one in this entire world will be able to tell you. You have to experiment, and this is where you comes into a picture. So it's the experiment out of that. So you will try to test, okay, fine. So this learning rate, that learning rate, and then you will try to find out a new value of a m over here. So every time I'll try to find out the new value of m. Every time I'll try to find out, right? And every time I'll try to evaluate that, okay, fine. So this value of m, so how much residuals I'm able to get, whether I'm able to achieve residuals or dr by dm is equal to 0 or not by using this value of m or this value of a c. Because here, right, so here, if I'm not able to find out, so to define or to derive something in this equation, so can I say that b is required, m is required, point is required, and your y is required? Yes. So can I say that if I will be able to see, or if I will be able to find out the value of like a b, m, or b is nothing but it's a c, right? So can I say that if I will be able to get a value of c, m, x, and y, I will be able to evaluate whether it's tending to 0 or not? Yes, everyone? I will be able to find out, right? This is what we are looking for. So we will keep on doing this kind of things again and again and again, unless and until we are not going to converge. Converge means minima tending to, or you will not be able to find out the minima point where this factor is equal to or close to a 0. So every time you will try to find out the value of m. Every time I'll try to find out the value of m, right? So can I say that, let's suppose, let's try to use this equation, right? Okay, so let's try to use this equations directly over here. So I'll just try to give you again a same thing, weight and height over here, right? So let's suppose weight is equal to maybe 60 kg, height is equal to 5.1, weight is equal to 62 kg, 5.3, weight is equal to 65 kg, maybe height is 5.5, weight is equal to 72 kg, 6.1, weight is equals to maybe 40 kg, maybe height is equal to 5.1, something like that I have given to you. Yes. Now here, this is the equation, y is equal to mx plus c. Now weight and x is representing your height. Now just by using these two data, right, just by using these two data, first two data, tell me what is the value of m and what is the value of c, just by using first two data. Then we will try to do a manual calculation even for our new value of m. Yeah, quickly. So I think last time we have done that, right? Okay, Deep is saying 10 and 9. Is this correct? So anyone who can confirm? 10, 9. Is it correct? M10, C9. Yes or no? Okay, M is equal to 10 and C is equal to 9. M is equal to 10, C is equal to 9. Fine. We are able to get it. Now what we will do, we'll not consider all the data sets. Actually, originally it's been considered as all the data set because summation symbol is mentioned, right? So I is equal to 1 till m is considered, but that calculation will be like a hectic, unnecessary, we'll end up doing a huge amount of calculation. So we are just trying to understand how this equation actually works, right? Let's try to understand in this way. Yes. So here, right, so here I will try to find out maybe a delta of EM. Now, what will be a delta of EM, by the way? Anyone? What will be a delta of EM? So can I say that delta of EM is nothing but this one? So XMC plus XC plus 2XY minus 2XY. Yes. So XMC. Okay. So XMC, this is the equation that we have derived. And then XC minus XY. XC, I think it will be plus, right? And what will be a delta of EC? So can I say that delta of EC is nothing but it will be what? So C plus MX minus Y, right? So C plus MX minus Y, I believe. So C plus MX minus Y. Okay, it will be XC plus MX square, I believe. So XC plus XY is fine. XC plus MX square. So now it's correct. Yeah. Delta E. Now, so here, I'm just talking about like equations which we have received after dividing by 2, right? That is the equation which I'm talking about. I think this equation is correct, right? I don't remember. Actually, no one remembers. If I have to like do it again, so I can maybe derive it and then I will be able to find out this value. Okay. Okay, fine. So this is the equations that we are able to find out, guys. And now what we have to do is that let's try to find out delta E and delta C. Now, this is a points I have given you. Let's suppose this is the point number 1, this is the point number 2, this is point number 3, this is point number 4, this is point number 5. Okay. So now you have already derived something with respect to point number 1 and 2. I'm just giving you an option. Again, this is not the ideal way, but with respect to point number 3, give me a value of delta E and delta EC. So you already know about MNC, right? You have already like got to know about MNC. So MNC is like a known things for me. So now give me a value of delta of EMC and delta of E of C quickly. Yes, so I think we know a value of X, I told you. So this is a point you are supposed to consider, right? So I think we all know about a value of X. X is nothing but it's going to be 5.5. What is my Y? Y is nothing but 65. So I think we know X, we know Y, we know M, we know C. So now give me these two values quickly with respect to point number 3, as I said. Okay, so EC is equal to -1. Okay, so what is EM? Okay, someone is saying -1. EC is -1. Okay, and this one is minus 5.5 that we are able to receive. Now, if I'll ask you, change a value of M. Yes, change a value of M. Give me a new value. So last time you have drawn this line. Now, after observing these things, right, after finding out a residual, because here you are finding out the residual. Again, this is not the ideal way of finding out the residual, because residual is a summations of all the terms, right? All the data set that we have. This is how I will be able to find out the residuals. We have a 5 data. Now you have to do a very long calculation. I'm just avoiding it. So purposely, I'm not considering. Tomorrow, don't tell me that, no, this is not a correct way of finding a residual. I'm aware about it, right? This is not a correct way. I'm just trying to show you a representational way. Yes, hope you are able to understand that part. So how equations internally works. In my original equation, I have already written summation. Okay, so here, right? So here, try to find out a new value of M. So you have observed that this is not equal to 0, right? Is it equal to 0? No, right? So am I supposed to stop changing the value of M or C? Or I should do some other calculation as well? Am I supposed to stop learning something? How I'm trying to learn, how I will be, what is called as learning, or what I'm trying to do. So learning is nothing but continuously I will try to change, I will try to adopt a new value. How I'm adopting, this is how I'm adopting. So tell me the value of new value of M and new value of C. Yes. So I'm supposed to find out a value of E, like I'm supposed to find out a value of E and C, EM and EC in such a way that it should tend to 0. But here I'm able to see that no, these values are not equal to 0. These values are not tending to 0. So can I say that I'm able to get this error, right? Because maybe I'm just like somewhere over here where there is some DE by DM and DE by DC I'm able to find out. Yes. So I'm able to find out, right? Now I'm asking you, can you please try to find out a new value of M and new value of C for me? Now, what is the equation for new value of M and C? So can I say that to find out new value of M and C, so M old minus eta of delta of EM and C old minus eta of delta of EC, right? So can I say that I know value of this one? Let's suppose I'm going to fix this one because we know that this is the learning rate. This is called as learning rate, which gives me a control. Here I'm able to find out a huge error. It's not like I will try to change this error by this volume, right? So this is nothing but a learning rate. Now someone is asking me what is eta. So don't go for a walk in between a classes. In your previous slide itself, I have explained learning rate. So if you are moving or going out for like a walk or something, so in that case, it will be a problem for you. You will not be able to understand a complete thing. Yeah. So don't go for walk. It's an important things that we are discussing. And in this way, you will not be able to find out our discussions even in a single YouTube videos over a whole internet, plus not even in our books. So try to focus here. And this is a one-time job. So once you will be able to learn, second time you don't have to even attend these classes. You will be able to understand how machine is learning. A very honest, like a advice to all of you. Okay. So here, right here, my idea is to find out what? My idea is to find out a new value of M, new value of C. Now, what will be a new value of M and C? So old. So yes, I'm aware about the old one. Already I'm aware about the old one, right? Which is giving me this error and this error. So I'm not able to achieve delta of EM or delta of EC is equal to 0, which was my ultimate objective. So this is something which I'm able to find out. Eta is nothing but it's a constant term, which is learning rate, which we are going to define. It is going to control if we are changing the values, then like how this values I will be able to, or how that changes I will be able to control, right? So let's suppose I'm going to define value of eta is equal to 0.001. Right? Now calculate M new and calculate C new. We will observe. So just do it quickly. What is the M new and what is a C new? So M is equal to 10.0055. Okay. So M is equal to 10.0055. And what is a C? So C is nothing but 9.001. So can I say that we have done a minor changes? Yes, a little bit of changes we have done in M and C. Agree, everyone? Okay. Now with this M new and C new, right? Again, try to find out with respect to the same point. Again, I'm asking you to calculate these things with the same point. Point number 3, right? So again, give me this values. Now tell me what is the next value with respect to M new and C new. Quickly, guys, everyone. With respect to M new and C new, you have to consider this factor 0055. This fraction you have to consider, right? Now tell me what is a new value or next value of delta of E and delta of C. Yes, quick calculation. So Navneet, we have covered a whole Python. So now we are into ML part. Okay, so new C value. Okay, so EC. So I'm talking about EM and EC, delta of EM and delta of EC. So give me this new value of delta of EM and delta of EC. I would like to know that after finding out a new value of M and C, right? So I would like to know that after finding out a new value of M and C, so whether I'm able to reduce errors or not, this one or not, right? So MNew and MC, we are able to find out, right? So now Lahari is saying that minus of 5328, right? And what is our delta of EC? Delta of EC is equal to minus of 0.9687. So guys, can I say that we are converging? What was the objective? What was the objective of finding out delta of EM and EC? So if you will just compare these two values, so can I say that we are trying to converge? Means we are trying to attend a point where it is tending towards a zero. Yes. One more time, if I'll, so based on this value, based on now this new value, right? Based on this new value. So again, if I'll ask you, find out M new, where M old will become this one. M old will become this one, and you have a new value of this EM and EC, right? So can I say that again, I will be able to find out error, right? Which may be lesser than this one. And in this way, if I'll consistently keep on doing these things again and again and again and again, right, I will be able to reach out to a point where actually it will be equal to zero. So are you able to get this objective, get this idea? Yes. So this value of M and C that we are trying to find out again and again, and this delta E and delta C, this is called as learning. This is a definition of learning, right? So when we say that we are trying to learn something, what we are trying to learn, learning doesn't mean that you are defining y is equal to mx plus c. That equation is not called as learning. Learning simply means that what we are trying to learn, what we are trying to adopt, right? A new value of this one, and this is called as gradient descent. So in many places, in many diagram, in many GIFs over the internet, you will be able to find out this kind of a things, right? This kind of a things, or somewhere you will be able to find out some Giphy kind of a picture where things are moving from here to here in this particular way, right? So how we are trying to move, or how we are trying to find out a new points each and every time. This is how we are trying to find out this new points each and every time. And this is how we are trying to converge, right? So someone is saying ball rolling. No, it's not an example of a ball rolling. I would say it's a kind of an example. So ball rolling, yes, you can relate, but that is not a correct assumptions or correct scenario. You can relate a mountain climbing and when you're going down from the mountain. So somewhere you are like you're just trying to, last time I have explained you, right? I have given you an example of mountain. So whenever you will be on a mountain, so on a 3D space, so you will try to find out a nearest point. So where you can go and you can hold, then a nearest point, then nearest points in a zigzag manner, right? So you will try to come down through a mountain. These are the same points we are trying to achieve. So how it will be able to achieve, how it will be able to find out a new point each and every time, right? By finding out this one, right? So this approach is called as learning, actual learning. And here, as you can observe, so previously this was the value. Immediately we have just done this calculation with respect to random data, right? It's not like we are doing this calculation with respect to some predefined data. I have just written down some data set, right? Which is having some sort of a relations, like a relational data I have taken over here. And with respect to data, so we are able to find out these things. So every time I'll keep on doing these things, keep on doing these things, unless and until I will not be able to observe what delta of E and delta of EC, delta of EM and delta of EC is equal to 0. Yes. how n is calculated. By the way, it's not n, and I told you don't go for a walk. It's a eta, and it's called as learning rate, and it's a constant. And range I have already defined over here. So according to Google Tensor Board, range will be in between 10 to 0.000401, right? So how many of you are able to understand some chunk of learning, like how learning happens? Okay, so many of you 100%, some of you 80%. Someone is saying it's a too fast. Okay, is it too fast? Last time 3 hour, now it's 1 hour 20 minute, 4 hour 20 minute just for this one. And the people generally finish this particular topic in half an hour with thousands of likes over a YouTube channel. Yeah, so there is a difference. Yeah, so this is actually called as learning, right? So this is actually like a called as a learning. Just try to understand the meaning, what is called as learning. So every time we are trying to find out a new value of m, how we are trying to find a new value of m with respect to this equation, new value of m and c. So in this equations, we have this term, how we are trying to derive this term. So yes, properly we have derived this term. This term is coming from where? From a residual. Because what we have to minimize, a residual is something that we have to minimize, right? And what is residual? It's nothing but it's a distance between the actual value and the predicted value on the line. Yes. Yeah. So like this is something called as training. So when we say that we are trying to train something, right? So internally, what happens? This happens every time. It will try to find out this value, new value, again new value of residual, new value of residual. Here with respect to only one points we are supposed to find out, we are trying to find out like residuals, but in reality all the points will participate over here. So that's the reason. So I have mentioned in my equation, my original equations, that it will be a summations. It will be a summation of I is equal to 1 till m, where m is nothing but total number of the records that you have, or total number of the rows that you have at any point of a time. And this same approach is called as gradient descent. So when someone will tell you that explain me a gradient descent, right? How you will explain a gradient descent, right? So you will start from the equation residual is nothing but y minus y hat. Now what is y hat? It's nothing but mx plus c. Now I'll try to find out the square of this residual. So I'll try to expand this one. So y square minus of 2y mx plus c plus mx plus c square. Just expand it, right? Expand it. That's it. Nothing else, right? And then try to find out what dr by dm, if just with respect to one variable, if I have to explain. So fine, dr by dm, I'll try to explain. Very simple, right? So mathematically, this is how you can relate, because we are trying to move from here to here, let's suppose, or maybe here to here, we are trying to move, right? So ultimately, what we are trying to do, we are trying to change the coordinates. That's it. It looks like it's a parabolic one, right? It's a parabola equation that we are trying to find out. But in reality, so the 3-point concept which I have shown you, right? Over there, what we're trying to do, we are just trying to move one point to another point, coordinate to coordinate. That's it. So how am I trying to find out the new coordinates? By using value of m and mnu and cnu. Simple, right? So gradient descent is not like a hypothetical concept, or not a concept that you can't explain with mathematics or in reality. But most of the people, when I ask, okay, fine, can you please explain me gradient descent? They just draw this one. They just draw this one, and they just like a max to max, they draw this one. And then I ask them, can you please explain? So they said that, yeah, this is the gradient descent. Then again, I ask, can you please explain? Right. And every time they will give me the same answer. Now, this is not the answer which I'm expecting, because I know that you are able to draw this particular picture. That doesn't mean that you understand a gradient descent. Yes. So this is what, and if you're able to understand this one in your deep learning class, I'll try to show you a very lengthy and long derivations in very, very simple way, right? Extension of this same thing. So here, right? So minus, okay, someone is asking why minus, why not plus? See, minus is a convention, but delta is always going to give you, minus is nothing but, so we are just always trying to decrease, right? But delta of E always comes with the sign. So it will try to cancel out if we have to add something. Minus means we are descending, right? We are descending. We are not ascending. We are always trying to go down. If this is the situation, so in that case, what I will do, I'll try to add. Yes. Yeah. Deep learning is black box or virus. Again, unnecessary questions which I have already answered 1,000 times. So not going to entertain. Learn first of all. Then you will be able to figure out automatically. Okay. So hope this concept and this idea is clear. Now, if I'll talk about the implementation part, right? Believe me, in one line of code, right? Whatever I have discussed in one line of a code, we can do it. So code wise, you don't have to write a code. Very simple, right? So you don't have to worry about the code part. Code is not going to be that complex, right? But yes, what I believe is if you are able to understand a mathematical intuition and why and how actually it's trying to learn something, what is actually called as learning, right? That will help you out a lot, even in interview and going forward when you will work in a real-time project, right? Because everyone can write those one line of a code. Every like a Kegler or a person who do a copy and paste from a GitHub or somewhere, they all know about like what line of a code I'm supposed to call. But this explanation is something which is going to give you a lot of things. Okay, so this is called as learning. This is how it learns, and learning simply means that finding out a new value of m and c at any point of a time. Residual, I think we are clear on that particular part. So now I'll go back to my assumptions point. So I have written that in point number 1, I have made the assumption that, okay, data is supposed to showcase a linear tendency. Then only you are supposed to use linear regression. Otherwise, no. Okay, fine. Mean of a residual should be equal to 0. Average of all the residuals that I will be able to find out should be equal to 0. Now, what is and why this thing is important? Why average of residuals are supposed to be 0? The reason behind this one is, so let's suppose if I'm trying to move from this point to this point to this point to this point, right? And then if I'm trying to falling down over here, it should always, right? It should always try to give me or cancel out each and every residuals, because if residual will just keep on increasing, if residual will keep on increasing, so in that case, right? In that case, it is going to create a problem for me. So you are supposed to, because you're not learning, your learning tendency is not going in a convergence direction. So that's the reason. So we have a residual should be equal to 0. Error term not supposed to be, or here we have like clearly mentioned in my point number 3 that your error term at any point of a time, right? So your error terms are not supposed to be correlated with each other, right? So whenever we are supposed to find out, or we are trying to find out the errors, so error term not supposed to be correlated. So it's not like if you will know the error value, you will be able to predict the value of y. So there should not be any kind of a correlations. So if there is a equations, right? If there is a equations, and every time, so let's suppose someone has given me an error term 5.5, right? And based out of that, if I'm able to predict the value of y, then that equation is a not accepted equation. So this is again an assumptions that your error terms are not supposed to be correlated with your y, because error terms should not show a relation at any point of a time, right? So that's the assumptions again we used to like a keep again. So your independent variable x, point number 4 says that your independent variables are supposed to be not correlated with your residual. So residual that we are supposed to find out, right? So it's not like your residual should show a tendency where your residuals are related with or correlated with what? So your residuals are supposed to be correlated with X? No. So you are not supposed to build any kind of equations where your residuals should show some sort of a correlations with your X or even your Y. So with respect to X, this is having a specific name. This is something called as exogenity. So here I have mentioned that X and residual must be uncorrelated, right? So this point is called as exogenity. This is having a special name. You have to remember this term, right? So if in interview someone is asking you that what is a exogenity, so exogenity is nothing but a relationship between, so if there is no relationship between my independent variable, right, which is X. So if there is no relationship between my X and my residual, so that particular phenomena is called as exogenity, right? So it is not supposed to be like a correlated. In third number points, I have already mentioned that it is not supposed to be correlated with your final Y. Means if I'll give you error again and again and again, and if you are able to predict the value of Y, that equation you are supposed to reject. You're not supposed to accept that equation. Again, very simple. Yes, this is what point number 3 says. Now point number 5 says that your error term must showcase a constant variance. Means it should it must like a decrease or maybe increase or something like that, right? It is supposed to showcase, means constantly it is changing, your error terms are changing. So yes, I think we are able to prove it, right? So can I say that our error terms are changing here? Our error terms are changing, right? So again, if you will try to find out a next value of EM and EC, again it will show you the same tendency. It will change. Yes, so it will try to change. Now here our next point says that there should not be any multicollinearity, right? Now what is the meaning of this multicollinearity, or like a what is like a multicollinearity? What is this term called as like a multicollinearity? So if there is a relationship between your X and X itself, so let's suppose if I have taken a multiple columns, again this term will come into a picture. So let's suppose if I have a multiple X values, X1, X2, X3, X5, right? So if X1 and X2 is showing a relationship in between, in that case, that data set is called as multicollinear. For example, I'll give you, let's suppose I have X1 and I have X2. Now, if I have this kind of a data, means if X1 is moving, X1 is increasing, X2 is also increasing. And both of these things are what? It's a independent columns, means my feature variable, right? So this situation is called as basically a multicollinearity. So your data set is not supposed to showcase a multicollinear condition. What is the condition it is supposed to showcase? It is supposed to showcase a relationship between X and Y, not between X and X. I'll tell you even in later stage when I'll show you some examples, right? Practical examples that why we are supposed to avoid these things, right? If your data set is a multicollinear, it simply means that you are not going to derive or you are not going to get new features. Although you think that there is a feature, but there is no feature. There is no value you will be able to get if you are going to keep that particular feature. In that case, you have to drop that particular column, right? So multicollinearity is a phenomena or a situation, so where there is a relationship in between X and X, you will be able to find out. Exogenity is a phenomena where X and a residual term, the R squared that we are trying to find out, is not related with each other. So multicollinearity, exogenity, remember this term. These terms are very, very important, and people will ask you a direct question in your interview, right? People will tell you, okay, fine. So can you please explain what is a multicollinearity, right? By giving some example. Can you please explain what is a exogenity by giving some example, right? So these are the direct question, and yes, you can expect that, right? So the error term have a constant variance. So here I have mentioned error term must showcase a constant variances, which yes, my error terms is showing delta E, delta E of M, delta E of C is showing me that variances, and that particular variance is again having a specific name. This particular 5 number points means error terms must showcase like a constant variance, and this is something called as homoscedasticity. Homo SCEDAS. So this three term, exogeneity, homoscedasticity, and multicollinearity, you are supposed to remember these three things. And these are the new words. So for sure, residuals is again, so exogeneity is related to a residual. So there should not be any kind of a relationship between residuals and the X values. Again, what is homoscedasticity? So error term should showcase a constant variances, right? That is something called as homoscedasticity. There should not be any kind of a multicollinearity. So what is a multicollinearity? Relationship between X and X itself. That is something called as multicollinearity, right? So these are nothing but the 7 points which I have written down over here is nothing but it's an assumption. So whenever you are going to build a model, right? Whenever you are going to build a model, you are supposed to keep these points in a mind, that whether a model which I have built or equations which I'm trying to find out, model nothing but your equation. That's it. Y is equal to mx plus c, right? So if I'm able to find out m and c, that is something called as model. That's some basic definition of model, right? That mathematical equation. So these are the 7 points which you are supposed to keep in mind. The last term says that error terms are supposed to be normally distributed. So which is again derived from where? So which is again derived from here, right? Because mean is equal to 0. So standard normal distributions, if it is going to face, and if it is going to build this normal distribution, it simply means that on this way and this way, in both the direction, it should be distributed equally, right? So whenever, let's suppose if I'm trying to find out y is equal to mx plus c, so value of m and c, if I'm trying to find out, what I will do is I'll try to validate all of these points, whether there is some exogeneity, whether there is some homoscedasticity, whether there is some multicollinearity between our data, whether my error terms are 0 or not, right? So I'll try to validate, I'll try to verify on each and every point, and then I will say, yes, my model is a good one. Now, the approach which I have followed to build a model is a good one. Not just this much. We have other terms as well. So I'll try to introduce all those terms. But yeah, so exogeneity, homoscedasticity, and a multicollinearity. Just remember this particular term. Now moving ahead with the next one. So here, let's suppose I'm able to build a model. Let's suppose I'm able to find out m and c, and now we know how we are able to find out value of m and c. What is the next thing that we are supposed to find out? So we are supposed to find out that how accurate, right? So how accurate our model is. This is something that we are supposed to find out. Let's suppose I have drawn the line, right? So my work is done, but no, my work is not done. So let's suppose this is a thing, right? Let's suppose this is the thing. I have drawn the line, right? Now this line says y is equal to mx plus c. I know that there are some points over here, but if I'll be looking for a prediction out of lines, so it is going to give me a prediction on the line itself. Okay, no issue. So I will be able to get a prediction over here, although points are here. So this is my original y, and this is my y hat, and this is my original y. Okay. So here, if someone is going to ask, let's suppose you have built this equation. Now you are telling me that, okay, fine. So I have done my work, and I can productionize it. I can productionize it so that others will be able to test, and others will be able to do some prediction, some kind of forecasting. But before you will productionize, I'll ask you one question that, okay, have you tested your model? You will say yes. Then I'll ask you how. There are multiple ways of doing a testing. Going forward, you will get to know multiple way, but one way, right, as of now, which you should know as a beginner, is I'll ask you a question that what is the accuracy of your model, right? So how you are going to define accuracy of your model? So if, let's suppose this is the model, this is the line which I have drawn, right? So what is the accuracy of your model? So how you will be able to define a accuracy? So you will be able to define an accuracy by using a R-square statistics. So there is something called as R-square statistics. It is again coming from the same residual point, but formula wise it is different. So your R-square statistics says that I will be able to, right? So you can define an accuracy of a model by using this one, and which is nothing but, right? So again, can I say that accuracy will be in between 0 to 100% or 0 to 1? Yes. So accuracy will be nothing but 0 to 100%, right? Okay. So R square says that, fine, just do one thing. Just try to do this. Yeah. RSS by TSS. Sorry. RSS by TSS. Now, what is the meaning of this? This is the equations by which you will be able to define the accuracy. So why we are using this equation? That is the first number question. Second number question is, what is the meaning of RSS and TSS, right? So RSS full form is nothing but residual summation of square. And TSS is nothing but total summation of square. Now, how I will be able to calculate RSS and TSS? Let's try to understand that particular part. Yeah. So RSS is nothing but residual summation, right? So this is nothing but residual summation of a square, and this is nothing but total summation of a square, right? So this is something which you will be able to find out. Now, what is RSS? So let's suppose for these data points, if I have to calculate RSS, residual summation of a square. So can I say that residual summation of a square will be nothing but this distance, this distance, this distance, this distance, this distance, this. So if I'll try to sum up all these distances, or in neat and clean way, if you want me to draw, right? So your residual summation will be nothing but this plus 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 this. So all this red mark, right? Red mark, if I'm going to if I'm going to calculate the summation of all this red mark, because this is nothing but it's a distance which it is representing, right? So can I say that there will be a coordinate x1, y1 or something like that? You will be able to find it over here. So can I say that I will be able to find out the distance between these two? Yes, we all will be able to find out distance between these two. So likewise, I will be able to find out distance between all, right? I will be able to find out distance between all, right? So that is something called as RSS, residual summation of a square. Can I say that I was using a same residual summation of a square for my delta of E with respect to like a C, and delta of E with respect to like a M calculation? Same thing, same derivations we have done, right? So residuals we have used. Here we are talking about R statistics. That's a different thing, right? To find out how accurate my model is. So can I say that if this residuals will be less, right? If residuals will be less, in that case, my I can say model will be more accurate. If summation of this whole residuals will be less, right? Let's suppose I'm able to find out like a residual summation of residual square, right? Summation of RSS1, summation of RSS2. Now this one is giving me, let's suppose 100, and this one is giving me, let's suppose 90. Now which one is a better model? Which one is a best line? So can I say that RSS2 is a best one because residuals is less over here, right? So for sure, the second one. I think we all understand that particular part. Fine. Now here, so this is going to give you a distance, right? You have to find out what? Accuracy. Accuracy will be in between what? 1 to 100, right? So 1 minus, if I'll try to keep 100 or some distances over here. So can I say that it is not going to like, it is never going to be 100? Or it is never going to be in a value in between 0 to 1, right? It is never going to be a value in between 0 to 1. Okay, no issue. So it is like a, but we have to find out some value in between 0 to 1. Then only I will be able to define some accuracy, right? So I can't tell you like, okay, fine. So 1 minus some hundreds or some, this is the residuals. And in terms of residuals, I can't tell you. If I'll tell you that one model is giving me 90 as a residual. Can I say that you will not be able to understand that whether it's a accurate model, it's not accurate model. But if I'll tell you that, okay, fine, accuracy is 90%, right? R square 90%, you will be able to understand very quickly that, okay, so for 90% of the data, it's working fine, right? That is the reason. So in a denominator, so we are trying to divide it by TSS so that we will be able to find out the exact ratio. Now, what is this TSS? It's a constant term, right? So what is the meaning of TSS? Total summation of a square. How do we calculate it? Let's try to understand. And then you will be able to understand even this particular part. So here, right? So here, I'll just try to like draw one new line, I believe that will be fine. So, okay. So here is like data points that I have. Yeah. And maybe I can draw one line. Yes. So I can try to just like draw one single line over here. And can I say that for every point we have y? Yes, everyone, whatever point that we have. So can I say that we have a y value, right? Otherwise, how I will be able to represent something in our 2D coordinates? Yes. So we have a y values. Can I say that I will be able to find out average of all the y? Yes, I will be able to find out average of all the y. Okay. So now this brown point is representing average of all the y, let's suppose. Fine. Okay. So this one is representing, so this line is representing what? This line is representing a average point. Okay. This is the average of y it is trying to represent. So now I'm just talking about a TSS, nothing else. Yeah. So what is your TSS, by the way? So TSS is nothing but it's basically a distance between your y and y average. What is RSS? Distance between y and y hat, right? So that is the distances. Y hat square is something called as RSS. What is TSS? So can I say that this is a distance between this and this? Summation of all the black points, black lines, vertical black lines, right? All the vertical black lines, right? This is something called as this distance. Summation of this entire distance is called as what? TSS. Can I say that this TSS is going to be a constant one? It never depends upon your line. It just depends upon your data. Can I say that? So for a particular data, your TSS is never going to change. Constant. It is going to be a constant one, right? Yes, everyone. Yeah. And can I say that TSS will be, right? So like a TSS will be a maximum distance for any kind of a or summation of all the TSS is nothing but it will be a maximum summations or maximum distances you will be able to find out. Can I make this statement? RSS is what? RSS is trying to attend a minimum value, right? TSS is what? TSS is basically a maximum value or maximum distances you will be able to find out between any data and any kind of a plane, right? Okay, so here TSS, this TSS is nothing but just a distance between data, original data, and your line, the average line that we have. Yes, so this is a TSS, a total summation, which is going to be a constant at any point of a time. This is going to be a variable, right? So as I will change a line, this will change. Simple, right? And this is going to be the maximum one. So here, that's the reason. So in a numerator, so we have this one, and in a denominator, we have this one. So we are trying to divide. So can I say that if this is going to increase, this is going to increase, RSS is going to increase, right? So this entire term will be increased. And this is the maximum, right? So any point of a time, so if you're trying to divide something by maximum, right? So let's suppose maximum is 100, and in between 0 to 100, if you're going to divide any point, you will be able to get some value in between 0 to 100. So here, right? So here we have a RSS and here we have a TSS, and it's if RSS is going to increase, residuals is going to increase. So this entire component will increase. So can I say that whole value of R square will decrease? Because it's a 1 minus this one, right? So if this component has increased, for sure, this whole value will be increased. Yes. Can I say that if RSS will decrease, this whole component will decrease and this R square will increase? Yes. So if RSS is decreasing, it simply means what? My model is supposed to give me a more accuracy. Yes. My model is supposed to give me a more accuracy. If residual is increasing, in that case, my model is less accurate. So simple. So this is the definition of R square. So R square is nothing but it's called as R square statistics in an original term. And R square is basically statistics which tells you how accurate your model is. Concept is very simple, residual concept based on that. So it is going to tell you that, okay, fine. So your model is accurate by 90% or 95% or 80%. So now if you will tell me that, okay, fine. So my model is 90% accurate. And if I'm agree with that, okay, fine. So now you can productionize. I'm allowing you to productionize a 90% accurate model, then only you can productionize it, right? So R square is basically a evaluation criteria for every model that we are going to build. For each and every model, we are going to have evaluation criteria. How RSS depends upon TSS. RSS and TSS is not a related term. RSS is something which is y minus y hat square is called as RSS. Summation of I is equal to 1 till m. Y minus y mean square is called as TSS, right? So this black line is what? It is representing a mean. So this is called as TSS. Summation of I is equal to 1 till m, right? TSS is equal to residual from a line passing through a mean. RSS is a fitted line. No, your understanding is completely incorrect. Yeah. So RSS is nothing but just a distance between these two. I told you, right? All this red line, just summation of distance of this, all these vertical red lines that we have, right? And TSS is nothing but this black lines that we have, all these black lines, vertical black lines, summations. So formula wise, distance between y minus y hat, y minus y prediction. We have done that so many times. And TSS is nothing but y minus y bar, which is nothing but y mean, right? So this point is representing a y mean. This line is representing a y mean, right? So this is the, and or maybe you can calculate distance from here as well. That is completely fine. So if some of you are not able to understand, you can calculate a distance, this distance, same distance which it is representing, just a representation. Yes. So RSS 1 plus RSS 2 is equal to TSS 2. How? I think we should look into that. Okay, no issue. Okay, so here you are supposed to build a model where model is supposed to fulfill what? Model is supposed to fulfill all of this 7 points, right? Then a maximum R we are supposed to achieve. Maximum R square or R square statistics we are supposed to achieve. In a later stage, I'll tell you that even R square statistics is going to fail. And this is where adjusted R square will come into a picture. So we'll talk about it. That is not an issue, right? Just try to digest first of all of these things that we have discussed in today's class, because sometimes it will be like too much for you to digest, and many of you will start getting confused, right? Because for a very long time you will not be able to focus. That is like a human things. It's completely fine. Yeah. Okay. So are we able to understand RSS, TSS, residual, and D by DM, D by DC, all those things? Right? If I'll ask you what is a meaning of, right, homoscedasticity, if I'll ask you what is a meaning of exogeneity, if I'll ask you what is a meaning of a multicollinearity, will you be able to answer? If I'll ask you, can you please explain gradient descent, right? Can you please explain mathematically how gradient descent happens? Mathematically, how I will be able to calculate M and value of C? If I'll ask you what is called as learning, right? So let's suppose I'll ask you, okay, fine, explain me a learning, right? So when you say machine is trying to learn something, now what is the meaning of learning? If you can explain, right? So will you be able to explain these things? Yeah. So few terms are new. I completely agree with it, right? So just, and again, it's not that tough, believe me, right? Once you will go through it once or twice, I think you all will be comfortable. So it's like fine. 50-50, try to make it 100%, right? So what if data is not homoscedastic? See, what is the meaning of homoscedasticity? First of all, homoscedasticity simply means that error terms should show constant variations, right? So if your error terms is not showing your constant variation, so in that case, a model building approach is wrong. There is nothing wrong with the data. First of all, try to understand a meaning of homoscedasticity, right? So it's nothing related to a data. It's related to a model approach that you're trying to build. So maybe you have to adopt some other approach to build a model, because the things that you're trying to build is not a correct one. Okay, so I'll take some of the question. Okay, so can you explain? Please review all of this step one more times, 10 minutes. No, first of all, go through a recording, right? Try to digest it and then come. Yes, that will be better. In this way, when I'll explain you again, you will be able to adjust. In 10 minutes, if I'll explain you again, you will not be able to digest. It's better to go through it. All the topics I have already repeated multiple times. If RSS increases, RS square increasing, correct? If RSS is increasing, so yes, your R square is going to decrease. R square is what? 1 minus something, right? So 1 minus something, this minus term is decreasing. It's a simple plain mathematics that your R square is going to decrease. R square is decreasing means what? Your R square decreasing means R square statistic decreasing means your model accuracy is less over there. This is what it means. Write down everything on your pen and paper and then try to interpret. It's just a plus minus kind of equation that we all have studied in our childhood. Those 7 conditions is for every model or for only linear model. What did I said? I think I said I'm talking about linear model, right, over here. So have I said that it's a generalized statement for every models? No. Shall we always keep eta is equal to 0.001? No, I have already given you a range 10 to 0.401. So that can be a range. It's experimental things. We generally keep 0.00001 or sometime like a 0.1, something like that. But that depends. That depends upon experiments. How we come to a parabola in gradient descent? Okay, so I already talked about the whole story, and now he's talking about how parabola. What is the equation of parabola, by the way? Can I say that's a secondary equation? Yes. So from there it's coming as a parabola. So just check the equations, right? So what kind of equations that we have derived? A equation of residual. Over there you will be able to get your answer. Okay, so any other technical question? How we can test homoscedasticity and exogeneity? We'll test it in a classes, so we'll talk about it. One down on point number 3. Can you please repeat what is this point number 3? By the way, error term is not correlated with each other. Yeah, so your error terms are not supposed to be related with a previous error and the next error. So it's not like it is showing some sort of a relations, because if it is trying to adopt relationship between errors, where it is trying to supposed to adopt relations between x and y values, so in that case your learning is not going good. I'll tell you one example, right? Point number 3. So let's suppose you have made a mistake, and again you are making a similar kind of a mistake. Then again you are trying to make a similar kind of a mistake, right? Which is related to a previous mistakes. In that case, that is something called as point number 3. Means your errors are correlated with a previous one. Means you are not trying to learn something. Means you are not trying to adjust or digest something. So if your errors are related, so this is how you can find out. What percentage of difference between train and test accuracy should be considered in overfitting? Depends upon the business use cases. You can't say that there is some constant term. Depends upon business acceptance. Example for a point number 3. Yeah. Okay. So is class over? So yeah, I'm just taking questions. That's it as of now, so that I will be able to clarify and something will be repeated, because what I believe is people are overloaded a little bit for today's class. Yeah, so tomorrow is Rakhi. So yes, I know tomorrow is Rakhi. So go enjoy and then come for the class. There is no holiday for tomorrow at all. I don't think that for Rakhi we need a holiday, right? It's just like a 5 minute of time it takes, right? So it's like there is no class cancellation. I'm not going to cancel your classes at all for like a Rakhi. Last Sunday it was a national holiday, so yes, we had a holiday. But for Raki, so no, not happening. We said two terms are related when multicollinearity. I think you will get to know. Yeah. So last week and started watching all the recording video. Yeah, Siddharth. So like complete the previous one and continue with the this one. I think we are going slow. We are not overloading. Going slow. Yeah. In interview, it can be asked to write the formula. See, when you know, see where I have written a formula. First of all, tell me in any places have I written any formula? I've just started with y is equal to mx plus c. Then a difference. This is where residual comes into picture. Automatically residual is square, right? And then after that, derivatives. After that, so delta of E of M, delta of E of C, right? So it's not like we are remembering anything. It's not, everything is very like related to each other, right? So it's not like you have to remember something. So don't try to see these things as your old school days stuff, right? This is not your old school days kind of a class. Here you have to adopt and relate. When you will relate, so automatically you will say that, okay, fine, so this is how this flow will be, and you don't have to remember in this way anything. So don't try to behave like that kind of a kid that you had maybe 10 years back or 5 years back. Yes, North India biggest festival. Yeah, I'm also from North India, so proper Bihar and Jharkhand. So Srini, can you please let me know where we can connect? I think Srini, we can connect over Skype is the best place for me to connect. If you can, I'm not able to see a ping from your side. Maybe I'm giving you my Skype ID. So no, sir. Let's ping over here and then we'll see. Yeah. So okay, next question. Next valuable question. In the book you have mentioned all this available in a books you have mentioned, so I have mentioned the books, right? You are not able to like look into that book. This is what happens, right? When we give a book, so people say, wow, you have shared a book, this book, that book, and then you will not even look into a book. And likewise, so in your system there will be hundreds of books. Just forget about everything, whatever I'm teaching, right? Everything is available even as a material inside your dashboard since a very first day. Go and look into it, right? Everything is mentioned, and we have created this material in such a way that when you will go for a final round or when you will go for an interview, right, you're not supposed to read out the complete books. Just read out these things and you will be able to revise it. So I think that will be more like beneficial and fruitful for all of you. Yeah. Okay, so fine. What are the value of MNC initially? So I think we all have find it out, right? Value of MNC initially. This is what we have done. When I go to the previous organization, highly appreciated. What topic I should focus on? As of now, try to focus on the current topic, ongoing topic. I think it's like more than enough. Yeah. Please explain homoscedasticity. Okay. So homoscedasticity is nothing but if you have like a constant variance in an error term. That is something called as homoscedasticity. Okay. So fine, guys. Again, I would like to know an update from the internship part. So how many of you are participating? How many of you have completed? So anyone, because from your batch, so I'm not able to see. So even yesterday and today, so we have verified and we have disapproved many projects because as we have very clearly mentioned in the beginning, that internship projects will be accepted based on our guidelines. It's not an internship where you will just do an EDA and then you will get a certificate. Not going to happen. So unless and until it is not going to fulfill our benchmark, our guideline. So offer letter is easy to get, but experience letter is not easy to get here in iNeu at least, right? So that anyone, and in your dashboard, I believe my team has already posted all the persons link, right, joining link. So I think that is also available, right? Anyone who can confirm? Yeah, completed and got the experience letter. Yeah, there are very few people who have received this letter, so there are very few people. So we are trying to scrutinize like things. Very strict instruction is given to a team that reject it unless and until it is not like fulfilling our criteria and all those guidelines that we have mentioned. Yeah, Bijoy, I'm aware about your project. So unnecessarily you are fighting over the mail. I have seen your mail as well, and actually you have made a mistake in your projects, right? And many mistakes you have made, and ultimately I have given approval that okay, fine, so approve your project. Second time, first time I think my team has disapproved your project, right? But again, believe me, your project was not that great. According to me, it was not great. Okay, so guidelines are already mentioned, I believe, right, Vishal? Okay, so guys, do one thing. See, if you are working on a project, let's suppose you have completed HLD, LLD, so try to send those things over a mail, at least for a verification. Many people are sending, we are verifying on a daily basis, so that at least we will get to know that okay, fine, so what is the progress. Bisal is saying that okay, link HLD architecture link is same. Yeah, LLD and architecture is same because in LLD itself we have given you architecture, right? So maybe when you are creating, you can separate it, there is no issue. But from our side, what we have done is, so in your LLD itself, so architecture is mentioned, so in both the places we have given you same link. That's a whole story behind that. Okay, just suppose if you are working on LLD, HLD, architecture, whatever it is, so keep on sending us, right? So keep on sending us like your updates that okay, fine, so this part of HLD I have done, I'm stuck over here. And from next week or maybe tomorrow onwards, those who are going to send an update, those who are going to showcase like a good updates over there. So actually last time in my DLCV and LP batches, I have created two separate group means I have just given them a dedicated project and they were working on those projects, and complete group, believe me, over in that particular group. So there was a people from like a 0 experience till 15, 16. I think Arun sir was there. He was having like a 18 year of experience somewhere, 18, 15. So this kind of people was there. So in total, 25, 23 people was there. All of them are able to make a transition easily. And we have closed that one with the 100% last week itself. Only one person was left. His name was Santosh. He was having like a 15 year of experience. And finally, even he got placed. So there was only one person who was left. In the similar manner, for your batches, I'm going to create a multiple squad of people who are interactively participating into their internship, right? I think you all have joined. Those who have not joined, so yes, you can join in your own project or maybe with someone. Even link is given to you in your dashboard. So like a project. So by next week, I have a plan to create this kind of a squad, because a problem with me is that I'm getting so many job offers and opportunity, right? Many referrals, because it's a regular task for us, and I want you to push your resume. So this is what I do. I create a squads and then I'll start like a pushing all of your resume over there. I start giving you a reference even without the completion of the batches, right? So you can start giving interviews. You will fail, it's completely fine. That is not an issue. But yeah, so these things will be given to a squads, a different kind of a squad, and that is going to happen from next week onwards. So just a reminder to all of you: start working and keep on sending us update that okay, fine, so this is the work I have done, and I think we all know, right? So some of you are my favorite already, right? So even last time I have given you extra batch access. You are, I know, even if I will not be there, still you will be able to make a transition. You don't need me, right? You guys are like sufficient enough to make a transition, honestly speaking. There are some people who need some sort of assistance. There are some people who need a lot of assistance. So these are the three categories. So start working on that, right? And start looking into your part. And again, for, can I apply for the interns also or only for the job? No, like whatever opportunity we used to give. See, internship is free and it's open for everyone, right? So everyone knows about it. Job referrals. So we always give a job referral. Simple. Means you can go, and that will be, we will not even come in between. It will be in between you and company. Simple. So we will give you a direct referral. This is something that happens from our like personal contacts, and from like multiple communities that we have already built, and multiple networks. And then next year, February and March, so there will be a job fair from our end, right? In between, so we keep on getting so many opportunities, right? So let's push it. Even today, even now, we have like so many like opportunities, and that will be available only to those who are actually performing. Because when we are sending someone from our side, so we always make sure that we are sending a person who will not fail, at least by 80%, right? So they are not going to fail. So we always make sure these things from our side, and then only we are going to forward your resume. So that is the reason. So I create a multiple squads and everything. Is it necessary to do assignments or directly start with the internship? See, do whatever you want. At the end of the day, we have kept a very less amount of restrictions, right? I'm not keeping, I think it's a zero restriction that we are keeping anywhere. Even the assignments which we have given you, it's easy to complete, right? Even if you'll sit for 1 week, right? So it's not like we have given you a very heavy assignments which you can't complete in 1 week. 40% you can do it in 1 week itself. If you're not doing it, then yeah, that's a problem. Will you take an interview first? Yes, my team will do assessment. That's the reason. So we create a separate squad itself, right? So simple. I want you to do one thing, just work. If you're working, I know we can manage from our end. Whatever we have to do, we know how to do it. Okay, so fine, guys. I think we are good today, right? So I'll just close the classes. I'm looking for an update from your side in terms of internship, and I'm looking for a regular update from every groups, right? So your team lead may be like send regular updates. I think that will be better. We'll see. We'll review from our end, and then we'll start like helping you out wherever you will get stuck. This is the way we are supposed to run the entire internship. An idea and objective is very simple. And next week onwards, a squad will be created based on your groups, right? So for those squads, there will be a separate meeting as well. So at least review meetings and everything. I'll ask someone from my team to start conducting those things, because this is what happens for our squads that we used to create. I've completed 2 HLD and LLD. And always remember, when you are sending me HLD, LLD, or architecture, right? Don't copy and paste and send it to us, right? We are aware about our document. We will simple write one word over there without any reason, rejected. This is what I'm writing. So in most of the project, right? So because I have seen some of the project submissions where guys are not even, they've just done a copy and paste, right? They have not even worked at all. They've not even worked for 1 hour, I would say. Same document, same core, everything is same. They have just copy and pasted over there. And people from our side is not that fool. You can't like a fool them. Simple, right? So we don't give you even a reason. We simple right, rejected. Rejected means rejected. Now you are supposed to figure it out, that what you have to do next. Because if you are just doing a copy and paste, right, there is no point of even a discussions over there. When you will work, you will do something by your own. When we will see, yes, you are really working, right, then for sure we would love to discuss on those points. But if you're not doing anything, we'll write simple rejected. And then we used to get a mail, can you please explain rejected? We say no, we are not going to give explanation. What is the reason? Because we have not even worked for 1 hour. So if you're not able to spend even a 1 hour, why you're looking for explanation from our side, right? So internship portal is created for a real work, not to do just a very small or simple work over there, right? So that is a motto behind creating an internship. iNeu never create something to just like create a bubbles into a market. Yes, we have given this opportunity to everyone so that everyone can grow, everyone can work, but again with the same criteria. It's not like you will come and then you will do something and then we will get a certificate, right? So this is something that we don't believe. So fine, guys. I believe I'll start getting some HLD, LLD, and everything from your side, right? Think through it with some work where I will be able to see, yes, you have given some thought, you have spent some time, right? So don't just send us our document. We are completely aware about it, what document we have given to you, and then what we are expecting. So always work, because that is something which is going to help you out. If you just do a copy and paste and you will think that I'll get a certificate, believe me, whether I'm going to give a certificate or someone else is going to give you a certificate, it is not going to help you out, honestly speaking, right? Whether you are going to get a certificate by spending 3 lakh, 4 lakh, 5 lakh, or by 3,000, right? Your certificates are not going to help you out in your job and even after a job. The only thing which is going to help you out is your work. And this is something which will make your life easy. So, and that's the reason. So we have all this kind of a provision. Yeah. Keep always these things in our mind. Don't work for certificate. Work for always knowledge, experience, and expertise. So I have started simple project. Shall I need HLD and LLD? Everything is needed. See a guidelines. Whatever we have mentioned inside the guidelines, you have to follow every guidelines point by point, line by line, without any exceptions. Right? I'm trying to get one more experience later. Yeah, go ahead. Just get it as much as possible. Choose some tough one. Don't choose a basic one. I have seen many of you this time, you have selected a very basic project. I said, okay, fine. So it's good for starting, right? You can do that. But try to select some of the heavy one as well. And next week, guys, a squad will be created, right? A squad simply means that, so for whomever we are going to create a squad, you will be under our direct observation. Not just we will connect on Saturday, Sunday, and in the class. No, my team will ping you anytime in this week, right? They will ask you for the update. They will ask you, okay, fine. So where you are getting stuck, let's try to resolve it. So this is the meaning of the squad, where my team can intervene anytime and they will be like in a direct contact, and that too in a regular contact, right? So again, Vishal and I think Vinod sir, you will be the very first one who is going to be a part of it, I believe, right? And even I want you to like be a part of that. Apart from you guys, so there will be like other people as well. Yes. So fine. Just try to send a work, and with that, things will be done. Yes, from our side, we'll start creating it. So once you will keep on sending us like these things, we'll start sending you a link. Okay, fine. So you are the part of this squad, that squad, in this way. So with that, guys, thank you so much, and see you again. Whatever we have discussed today, please try to revise it. Things are already available inside your dashboard, right? Revision is very, very important. And let's connect tomorrow. I'll start with the practical tomorrow. Yes, and whatever we have discussed, we will try to validate it, that how we can code with respect to data. So tomorrow, I think it is going to be an interesting one, but theory is required. Step by step, and I will code. So you should know about the theory at least, whatever I have discussed till today. Yeah, thanks for coming with this squad. Yeah, that's like a common. We always do that. That's the reason. So we always keep on pushing one squad. Okay, this squad is ready. Now, whatever opportunity is coming, push them. Then again, next squad. In this way, we'll keep on moving. And we always keep this squad in our like a direct observation. Personally, I used to take care of it, this squad part. And under me, so Sunny is there, Paul is there. So even they comes into a picture. And Ravi is there, Kasali is there. So they used to observe from my side. Accountable, and that will be help a lot. Yeah, and they can ask you every time, like, okay, so there is no timeline and there is nothing, so they can ping you anything, like the way we used to work, right? So get into a call, let's start having a discussions and close it, and just to kill all the points, hurdle points as soon as possible. Anyhow, support team is there, but this will be this is something which happens in a dedicated way. So with that, guys, thank you so much, and see you again in the next class, which is going to happen tomorrow. There is no holiday. Good news is, right, we all have to join the classes. With that, thank you so much, and have a great day, night ahead. To be very frank, support team is awesome. Yeah, thank you. Some of you must be having complaints. That is also fine, but yeah, everyone is working, right? Everyone is people. So okay, so thank you so much, guys. Thank you.